Hey guys, welcome to Orion Aerospace. Today we're going to be talking about the thrust vectoring mount and some of the changes we've made to that as we prepare for our next flight. As you might remember from the last video, we talked about how the jankiness of our system has led to the unreliability of our rocket. Part of that is due to the thrust vectoring mount, of course. The first problem is these 9-gram SG90 servos. They're plastic geared, they're cheap, they come with basically any electronic kit you buy. They're not great for withstanding a lot of stress, especially with the motor firing. For the geometry we had for TVC 2, we had to print our own servo horns. This led to some problems because the teeth on the SG90 servos are tiny, and we couldn't get good enough resolution for teeth on the horns. This led to some kind of slippage, especially if we didn't glue the horns on good enough. Just kind of a janky approach to the geometry of the mount. The third problem is with our 6mm to 6mm coupling here. It's a little bit shaky, just straight out of the box. It's a little bit shaky, a little bit jiggly. This kind of led to some error in the mount. So what we decided to do is just a simple fix. We just wrap some electrical tape really tightly around it, kind of gets rid of that jiggle, makes it a little sturdier. Alright, so in order to make some modifications and changes to the top part of the thrust vectoring mount, I had to go into CAD and just kind of look over the entire mount, decide what could go, what needed to stay, and what needed to change in order to fit our new motors. So of course in TVC 2, we had the motors stacked on top of each other. They had the long 3D printed servo horns on them, which led to a kind of a 1-to-1 geometry on the mount itself. In TVC 3, I was able to separate the motors slightly. Even though they're slightly bigger, the MG90 motors fit side by side instead of stacked up now. They can use their standard horns, which allows for a different geometry, which I'll explain later. It's a little bit complicated, but it makes our mount essentially more accurate and more stable. So due to these design decisions and how well the software worked, I had to kind of find a relationship between the old mount and the new mount so that we didn't have to make any software changes, but the mount would still work. In order to do this, I spent quite a bit of time trying to come up with a geometric function just to relate the angle of the servo motor to the angle of the rocket motor. This became very frustrating after a certain amount of time. I had this massive function that I couldn't simplify, and so I sent a message to the Space Boys group chat, which contains Hugh, Jonah, and myself. And Jonah came up with the brilliant idea to just represent this in CAD, take down some data, and then put a best fit line to it. So I did that. So based on the geometry, I didn't think there was going to be a linear relationship that defined the servo angle to the thrust angle. But because we're only looking at a very small window of values, from about -20 to +20 degrees, it was actually represented very well with a linear fit line. So basically what this means is our new mount has an accuracy to a little bit over 1/2 degree, which is significantly more accurate than our last mount. So after working out the geometry and printing the mount itself, we finally got a mount that I'm fairly proud of. This thing is more reliable, it's stronger, it's lighter, and it's more accurate. So it basically improves upon TVC 2 in every single way. It's going to remove a lot of the error from the rocket itself, and I'm really excited to fly it. So another cool thing about the mount is that it's only 2 3D printed pieces. So basically we have to just print 2 things, throw in the servos, throw in the arms, and it's ready to go. This makes it very easy to repair if, of course, this bottom piece burns up, melts, anything like that. In some of the preliminary testing we did with the MG90 servos, we noticed that they have a slightly slower response time. This doesn't seem like it's going to be a problem, but until we fly the rocket, we don't know. So we're going to do some hold down tests, and that'll just tell us if these servos are actually going to work in the mount and give us some stable flight. As always, thanks for watching. Thanks for sticking with me through this TVC video. This is a project I've been working on for quite a while now, and I feel like I've finally gotten it to a point where it's optimized and condensed to where I want it to be. You might have also noticed it's just me today. This is because we're trying out a new format where we all work on separate videos on separate aspects of the rocket, although we're all working on the same rocket. This is because during the school year, we all go to different universities, and it's going to be very hard to collaborate on the videos. So just let us know what you think about this format. We should be able to get more content out more quickly now. Don't forget to subscribe on YouTube and follow us on Instagram at Orion Aerospace. We also have a Gmail, orionaerospace.liftoff@gmail.com. So go ahead and email us if you have any questions, comments, or concerns. Yeah, hope to see you next time.